Hi everyone, we are discussing the course of numerical methods and integral transforms. In this particular course, we are discussing curve fitting. In this curve fitting, we are going to fit an exponential curve and the power curves for the given data by using the concept of method of least squares. So in the previous video, we have seen how to fit a straight line and how to fit a second degree polynomial for the given data. Now in this video, we are going to see how to fit an exponential curve and the power curves using the concept of method of least squares with some examples. So now first we will concentrate on the exponential curve here. So here we are having two types of exponential curves. So this is y is equal to a into e power bx, that is one exponential curve, and the next one is y is equal to a into b power x. This is another exponential curve. Now one by one we will discuss how to fit an exponential curve, these exponential curves for the given data. First we will concentrate on this and later we will go for the second one here. So first I am going to discuss first type. So whenever we want to fit a exponential curve or power curves, for these curves we don't have any standard normal equations by using the method of least squares. Now what we have to do is, we have to convert these exponential curves in the form of a straight line as we discussed in the previous video. Now we will see how to convert this in the form of a straight line, that is y is equal to a plus bx. Now let us discuss this and we will take the help of these straight line normal equations to find out the normal equations for these exponential curves, to find out the values of small a and small b here. Now let us start. Let the equation be. So I have taken this equation y is equal to a into e power bx. Now my task is, I want to convert this equation 1 into this standard form, straight line form, y is equal to a plus bx. Now I will explain how to convert this into the standard straight line equation. Now for this purpose, I want to apply this log on both sides. So we are having two types of logs. One is log base e, that is natural logarithms, and log base 10, that is common logarithms. So here whenever we want to apply, then you can apply any one of these two logarithms here. So now I want to apply the natural logarithm, that is base e, on both sides. So once if we apply this, we got this log y to the base e. So log of y first equal to log of a into e power bx. So log y, you consider this log y as this. By default, log means here we are taking the base e. So log e, and once if you observe this RHS part here, that is in the form of a into b. So log a into b, that can be log of ab can be written as log a plus log b. Apply this procedure. Log a, that is log a to the base e plus second term, that is log e power bx. Now you write down this as it is, and now here in the log we are having a power e power, for the exponential function we are having a power bx. You bring this power to this in front of this log. We know this, we have the formula log a power x. So this can be written as x into log a. Now use that. So now we are having log e to the base e. So log e to the base e, we can consider this value as equal to 1. So 1 into bx. This is our equation here. So now we are having this equation in terms of logarithms. Now I will consider this log y to the base e with a capital letter Y, and log a to the base e, I will consider that value as capital A. And in the second term here we don't have any logarithmic functions, so you keep this bx as it is. So now once if you observe this one, capital Y is equal to capital A plus small bx. This is of this standard equation. Y is equal to a plus bx form. Here we are having small a, here we are having capital A, and small y, here we are having capital Y. Only that is the difference between this equation and this equation here. So we have substituted the capital Y. So wherever we are having log y to the base e, have replaced with capital Y, and log a to the base e have represented with log a base e represented with capital A. So by using these substitutions, we got capital Y is equal to A plus Bx. Okay. So you consider this as equation 1. Now, whenever we have discussed fitting a straight line of the form Y is equal to A plus Bx, we have the normal equations. That normal equations we have taken as summation x is equal to Na small a plus b into summation y is equal to Na plus b into summation x, and next one is summation x into y is equal to a into summation x plus b into summation x square. Okay, so here, since in the equation we are having small a, so I have taken small a here, and in second term we are having small b, I have taken small b, and small y here also I have represented with the same variables here. Now here, once if you observe this one, in place of small y we are having capital Y, and in place of small a we are having capital A. Except these two difference, the remaining equation is same. Okay, similarly, these are the normal equations. We are having a straight line of the form small a plus b into x, and this is also a straight line equation in terms of capital Y and capital A and small b. Just do these modifications for these normal equations. You replace that small y with capital Y, replace small a with capital A, and the remaining thing same. So by modification of this, we will get a straight line of we will get a normal equation summation capital Y is equal to n into capital A plus b into summation x, and summation x into y. Here we are having summation x into y. Here we are having small x. In this also we are having small x. So don't change that small x. Keep that small x as it is. So we will get summation small x into capital Y is equal to a into summation small x plus b into summation small x square. So like this, we have to take the help of the standard straight line normal equations, and from that normal equations we have to derive the normal equations for the exponential curve. This procedure we have to follow for all the remaining exponential curve and the power curves. So now, as usual, summation y, you solve these two equations, you will get a capital A value and small b values here. But whereas in the last, our exponential curve, this is our exponential curve, y is equal to a into e power bx. But in our exponential curve, we are having small a. But after solving these equations, you will get capital A here. We don't want that capital A, we want a small a value here. So for this, in order to get a small a value, in the beginning, in the modification we have seen, replace that we have represented that to capital A with this value. Capital A is equal to log a to the base e. So from this relation, I want to get a small a value. So from this, you will get small a is equal to e power capital A. So anyhow, we will get our capital A value, replace that capital A value and find out that exponential value. You consider that value as a small a value here. So now we are in our hand, we are having small a and small b. Now immediately you substitute that small a and small b in the equation 1. Then we can get our required exponential curve for the given data. This is the procedure we have to follow to find out that to fit an exponential curve for the given data using method of least squares. Now we will go for the type 2. So this is our type 2. So y is equal to a into b power x. Follow the same procedure what we have followed for the type 1. So here also I am taking log on both sides, log base e. So if you take log base e here, you will get log y to the base e is equal to log a to the base e, and this is log b power x to the base e. So as we seen in the previous, you bring this x to this, you will get x into log b to the base e. Now all the three terms in that particular equation is in terms of log. So you will replace that log with these capital letters. So this log y will replace with capital Y, log a will replace with capital A, and x, you keep that x as it is because we are having a small x, so keep that small x as it is, and now here having log b to the base e, replace with capital B. So once again this is also of the form y is equal to a plus bx. Now if you want to get the values of capital A and capital B, then we have to take the help of normal equations here. So now the normal equations, in order to get the normal equations for this equation 2, then once again we have to take the help of straight line y is equal to a plus bx. So whatever the modifications we want, you can replace here. So summation small y is equal to, use the same normal equations for the straight line. Just wherever we are having small a, you replace with capital A. Wherever we are having small y, replace with capital Y. And keep that small x as it is, and small b, replace the small b with capital B in the normal equations of a straight line. Then we can get, so these are the normal equations we will get. Summation capital Y is equal to n into capital A plus b into summation small x. We are not changing that small variable small x. You keep that x as it is here. And summation small x into y is equal to a into capital A into this. So these are the normal equations for this exponential curve. Next, after getting this normal curve, we know how to do. So solve these normal equations, we will get the values of capital A and capital B. But we don't want this capital A and capital B, because we have considered that equation of this exponential curve in terms of small a and small b. So from that, by taking the help of capital A and capital B, we have to get the values of small a and small b. For this purpose, we have taken capital A is equal to log a to the base e. From this relation, we will get small a is equal to e power capital A, and take the next one, capital B is equal to log b to the base e. From this, we can get our b is equal to e power capital B. Already in the previous step, we will get the capital A and capital B values. Replace in this, find out that exponential value. You consider that small a and small b values. So once after getting small a, small b, we know what we have to do. You substitute that values in the equation 1. Then we can get our required exponential curve for the given data. So these are the two exponential curves we are having. This is the procedure we have to follow to fit an exponential curve using the method of least squares. Now let us take one example here for fitting this exponential curve. So I have taken this exponential curve type 1, and this is the data he has given. Now for this equation, for this data, we will see how to get that fitting of exponential curve here. So as we discussed earlier, you follow the same procedure, taking log on both sides. So finally you will get this equation 2, and for this equation 2, you get the normal equations and find out these values here. So here small x, small y, these are the values we have given from in the data. So summation small x, in the normal equations we are having small x. So here we are having small x. So in the normal equations you will get summation small x. So you take that value, and here we will get summation small y, because we no need to find out this value, because in the normal equations we don't have summation small y. In place of that, here having summation capital Y. So we will concentrate on capital Y here. What is the relation we have considered for capital Y? Capital Y is equal to log y to the base e. So already we know the values of y. For each value you consider, you find out that natural logarithm values. So like this, you get all the values log y, or all the log values of y, and you find out the sum of this, you will get summation capital Y. And similarly get x square value, summation x square values. And now here in our normal equations we are having summation small x into capital Y. So for this purpose I am finding small x into capital Y. So this is our small x values, then this is our capital Y values. You multiply the first column and the third column values and write down here and find out the sum. So totally you will get summation small x into y is equal to 94.1442. So like this, whatever the values we want in the normal equations, we will find out that values by constructing this table. So once if it is completed, then we are ready to substitute these values in the normal equations here. So if you substitute this, you will get these two normal equations. and then solve that equations, you will get capital A and small b values. We want small b, keep that small b as it is, but here we don't want capital A value here, because our exponential equation we have considered as small a into e power bx. So here we want small a, but we don't want this capital A here. So by using this capital A, we will get the values of capital small a. By taking this relation, we have considered capital A is equal to with this value. Now from this you will get small a is equal to e power capital A. Substitute that capital A here. So find out this value, you will get that small a is equal to 9.4744. So now here we are having small b, here we are having small a. Now we are ready to substitute in the exponential curve. So here y is equal to a. In place of a I have taken a value. E power b. In place of b I have taken the value of b and I have substituted. This is our resultant best exponential curve for the given data. So this is the way, this is the process we will follow to fit a exponential curve for the given data here. And we can follow the same procedure for the second type also. Now, up to now we have discussed how to fit an exponential curve type 1 and type 2. Now we are going for the power curve here. So this is our power curve, y is equal to a into x power b. So we will consider this as a power curve for that, and you consider this as equation 1. So whatever the procedure we followed for the fitting of exponential curve, we follow the same procedure for this and convert this exponential, this power curve in the form of a straight line, that is y is equal to a plus bx, because for this power curve also we don't have any standard normal equations. So if you want to get a normal equations for this, we have to convert this into this standard form, straight line form. Now we know, follow this procedure, same procedure, apply log on both sides and then get the final equation of the type y is equal to a plus bx. So here log y, you represent this log y with capital Y, log a with capital A, log b with capital, small b, you keep this small b as it is, and here we are having that is x variable is involved in logarithmic function, so we will consider that as capital X. So these are the this is the straight line form of this an x power curve. So y is capital Y is equal to capital A plus b into capital X. Now according to these normal equations, so we know the normal equations for the straight line, use that. So wherever we are having small y, replace that with capital Y. Wherever we are having small a, replace with capital A, and wherever we are having small x, replace that small x with capital A, and keep this small b as it is. In both cases we are having small b, so no need to modify that small b, you keep that small b as it is here. So these are the substitutions we have applied. So the normal equations, see, so the normal equations for this one is, straight line is summation small y is equal to n into small a plus b into summation x. This is the first normal equation for the straight line. And the next one is summation small x into small y is equal to a into summation x plus b into summation x square. So from these are the standard normal equations for this type of straight line. Now this is also a straight line, but with capital Y, capital A and capital X. Just replace this. Replace small y with capital Y in these normal equations. Small a replace with capital A, and capital small x replace with capital X. So you will get summation capital Y is equal to n into small a. We are replacing small a with capital A. So n into capital A plus, we are not changing anything for b, keep that b as it is, small b. Summation small x, we are replacing that summation small x with capital X. So replace this. Similarly, in this also you replace that small x, small a and small y with these capital values. Now solve these equations. You will get capital A and small b values. So once if we get a capital A, then we have seen how to find out the small a. So use this relation and you will get our small a value. So now we will get small a value. We got the small a and small b values. Once after getting this small a and small b, immediately you substitute that values in the equation 1. Then we can get our required best fit for the given data. So this is the procedure we have to follow to fit an exponential curve. So now in this video we have discussed how to fit an exponential curve, type 1 and type 2, and the power curves. And with this we can complete the concept of curve fitting here. So in the next video we will go how to find out the root finding techniques. So they will give equations, and by using that numerical methods we will see how to find out the roots of these equations here. Thank you.